After this video, you should be able to use Venn diagrams to represent sets, subsets, and set operations. Venn diagrams use circles, and not just any circle, multiple circles. So it can represent one. Let's add one more. Let's drag it over here. So it uses circles to represent relationships. So if they have some common things, they should overlap. But sometimes if they don't have common elements, they are what you call disjointed. So let's just start off with how do we represent sets using the Venn diagram. It's basically just circles. Okay, so what we have here is a universal set of even numbers and set A with elements -2, 0, and 2. So how do we represent the universal set? We don't use circles, but we use rectangles actually. There you go. So this would represent all even numbers. So let's just use U here at the top left. There you go. So that's how you represent universal sets. How about the set? Now we're going to use circles. There you go. And let's just put A here to say that this set right here is A. Then we can just list out the elements inside of A. So inside of the universal set of even numbers, we have set A here that has -2, 0, and 2. There you go. So that is how you represent sets. Now, let's go on and represent subsets. Same thing. We have a universal set, so we are going to use a rectangle. Okay, there you go. Then we're going to use circles to represent the sets, but let's just first use one circle. Okay, let me label this. So we have the universal set here of all odd numbers. Then we have set A here with 1, 3, and 5. And for B, we don't need to put it outside of A, but actually inside of A. And there you go. And let me just label this with B. Every single element of B is in A, and you represent that or you denote that with B is a proper subset of A. This symbol right here says a proper subset, meaning everything in B, so we have 3, is in A, which is correct. Take note, every single set that we have, set A and set B, is a proper subset of our universal set. A is a proper subset of our universal set. Of course, B is one also. So that is how you represent subsets. Let's go on now to the bulk of this video, which is to represent set operations using Venn diagram. So you have, of course, the union, intersection, the difference, and complement. We have a given right here. So instead of saying even numbers and odd numbers, I'm just going to bound it between -4 and 8, and all of them are even numbers. So let's draw our Venn diagram. A rectangle right here, label it as U, a circle here, label it as A. Then let's put the elements of A here. So we have 2, -2, 0. Then we make another circle, overlap it with A since they have a common element, -4 and 4, and label this as B. And for C, there you go. So we have 2, -2, and 6. So for -2, we also have it for A. So we're going to put -2 right over here. No. So since it's overlap, I'm just going to erase that and put it with the overlap. There you go. And I'm just going to fix this. Excuse me. 4. There you go. And looking at our universal set, so we have -4, -2, 0, 2, 4, 6, and we don't have 8. So now we have our Venn diagram. We can answer the union. So we have the operation of union. So using the Venn diagram, we can shade A union of B. Looking at A, looking at B, we don't really care about C. I should label this. There we go. You're going to shade all of A and B. So I'm going to shade all of this. And we're going to put all the elements that are in the shaded area, which are 0, -2, 2, -4, 4. Then we have B union C. Same thing. You're going to look at B. You're going to look at C. We don't really care about A. So we have 2, -2, 6, -4, 4. And here. Sometimes questions will give you 3 sets. So what is the union of A, B, and C? You want to do it by 2s. So first, you're going to do A union B, then all of the elements there, union of C. But since we have the Venn diagram, it's much easier. Put all the shaded elements inside. So we have, of course, 2, -2, 2, -4, 4, 6. And that is how you answer union with Venn diagrams. Okay, so I'm just going to drag this down towards the intersection. So now we're going to talk about intersection, which are elements in A and B. Only want elements that are in both A and B. And for the Venn diagram, those are the overlapping bits. So we're just going to put 2 right over here. We don't really care about C. Next up, we have the intersection of A and C. So we're going to shade this area, A and C. We don't really care about B. There you go. So we have 2 elements, which is -2 and 2. And finally, we have the intersection of all 3. Intersection of all 3 is this region right over here. So it is just 2. That is how you answer intersection using Venn diagram. Then we have the difference, or the other name for it is actually a relative complement. Since this is for grade 7, I won't further delve down into it. But just know that the difference of 2 sets is called the relative complement. So here, the order matters. Remember, in difference of 2 sets, the order matters. A minus B is different from B minus A. So look at A and then look at B. You're going to get all of A, but not in B. So what you're going to shade is just exclusively A. We don't want the one overlapping in B. So the elements here we have is 0, -2. Next up, we have B minus A. Same sets, but the order is different. You look at B, you look at A. We don't want things that are overlapping. So just going to be all of this. We have the elements -4, 4. It is different. A minus B and B minus A. And finally, we have C minus A. Again, look at C, look at A, and just shade the area without the overlaps with A. So we just have one element, and that is 6. Next, and finally, we have the complement. So now we have the complement of A, which is basically everything that is not in A. So all of these except A. So you have -4, 4, 6, 8. Now I'm just going to put the shade there, and we're going to use the union with B. The not A is all of this, and B is all of this. So it's almost the same, but we're going to add 2. So it's -4, 4, 6, 2. Now, this one is the interesting bit because it uses parentheses. Now, what is the intersection of B and C? So that's the intersection of both of them. What is the complement of that? It's just going to be everything outside. Same thing with what happened with A. We're just going to shade all of this except the intersection of B and C. So everything except 2. We have 0, -2, 6, -4, 4, and then we have 8. And finally, we have this one. Usually these are the curveballs in tests. Let's just go by it one by one. So let's start with this one first. What is the union of A and C? So it is all of this. The complement of that is everything outside. Everything outside. So I'm just going to do this. And then, since all of these are not the union of A and C, we're going to get the intersection of B. So what is B here? It is going to be all of this. The B is here. But the intersection for them is -4 and 4. There you go. So that's how you answer it using Venn diagrams. But if you don't want to use Venn diagrams, which I encourage you to do because it takes time, then I encourage you to just use the set notation. Venn diagrams usually takes a lot of time. That is how you use Venn diagrams to represent sets, subsets, and set operation. That's it. End.